In this video, we are going to solve this problem. The graph of f consists of two straight lines and a semicircle. Use geometric formulas to evaluate each definite integral. So we have three definite integrals to evaluate. Now let's start with the first one. The integral from 0 to 2 of f of x dx. This is a definite integral, so we go from 0 to 2. So the region here is this one that I'm shading, and it's above the x-axis. So that definite integral would be positive. So equals plus. Now, what's the area of this region? That's a triangle, and the area is 1/2 base times height. So which is going to be equal to plus, and remember plus y because the area or the region is above the x-axis. Now 1/2, the base here is from 0 to 2, that's 2, and the height is from 0 all the way to 4, so it's 4. This gives us 4. So the integral from 0 to 2 of f of x dx is plus 4. Now let's go over part B. We want to compute the integral from 2 to 6 of f of x dx. This equals what? Now, when you look at the area from 2 to 6, you see that the region is below the x-axis, so we're going to multiply that by a negative sign, so minus. And since we have half a circle, we know the area of a circle is pi times radius squared, but we have half a circle, so we multiply by 1/2. And what's the radius of this circle? The diameter is the length from 2 to 6, that's 4, so the diameter is 4, and the radius is half the diameter, so it's going to be 2. So r here is 2, and we have that negative 1/2 pi, and then r, which we found to be 2 squared. So we get negative 2 pi. So the definite integral from 2 to 6 of f of x dx is equal to negative 2 pi. Let's go over the third one. C. We have the integral from 0 to 6 of f of x dx. This is equal to what? Now, we want to compute the integral from 0 to 6. And we have two regions. So let's go ahead and use the property of adjacent intervals. So we're going to break this into 2. And this is going to be equal to the integral from 0 to 2 f of x dx plus the integral from 2 to 6 f of x dx. So notice that to compute the integral from 0 to 6, I first have to compute the integral from 0 to 2 because I know how to compute that, from 0 to 2, and then from 2 to 6, and I add them all up. And I just computed the integral from 0 to 2, which is 4. So this equals 4 plus the integral from 2 to 6 is negative 2 pi. So plus negative 2 pi. Let me write this in parentheses. So we have 4 minus 2 pi as the answer. So the integral from 0 to 6 of f of x dx equals 4 minus 2 pi. Now as a problem, so you're going to use the same graph, but I'm going to give you this problem. And I want you to compute the integral from 6 to 7 of f of x dx. So we have the graph here from 6 to 7, and remember the height here is equal to 1. So you do that, and the second one, I want you to compute the integral from 2 to 7 f of x dx, and the third definite integral that you can do for practice would be from 0 to 7 f of x dx. So what you should think about here are adjacent intervals, exactly the way I did for part C, for example.